underground feeder, or off cable can sometimes be challenging to strip. Fortunately, several dedicated tools and techniques can make the process easier and safer. Firstly, dedicated wire strippers are a good option. These tools come with built-in blades and guides specifically designed for stripping UF cable. They provide precise cuts and minimize damage to the conductors. Secondly, automatic strippers offer another efficient solution. These tools use a motorized action to strip the insulation quickly and accurately. They can handle various wire sizes and types, including UF cable. Beyond dedicated strippers, other methods can also be effective. Some multi-tool pliers have wire stripping capabilities. While not as precise as dedicated strippers, they can be convenient for occasional use. Additionally, heat-activated strippers are available. These tools use heat to soften the insulation, making it easy to remove. They are particularly useful for thick or difficult to remove insulation. Regardless of the tool you choose, there are some essential tips to keep in mind when stripping UF cable. Ensure the blades on your stripping tool are sharp to avoid excessive force or damage to the conductors. If you are using a manual stripper or knife, score the insulation around the cable and gently pull it away. Be careful not to cut through the conductors. If the insulation is particularly thick, make multiple passes with the stripper to avoid damaging the conductors. Wearing gloves is also recommended to protect your hands from sharp edges or splinters. It's always a good idea to familiarize yourself with the stripping tool and practice on scrap wire before using it on live circuits. This will help you get a feel for the tool and avoid mistakes. When selecting a wire stripping tool, consider the following factors. Firstly, the range of wire sizes it can accommodate. Ensure that the tool can handle the gauge of UF cable you typically work with. Secondly, the ease of use and ergonomics of the tool. Look for a tool that is comfortable to hold and operate, especially if you'll be using it frequently. Thirdly, the durability and build quality of the tool. Choose a tool made from high-quality materials that can withstand regular use. The process of stripping UF cable starts with preparing the cable. Firstly, use a utility knife or cable cutter to carefully score the outer jacket of the UF cable. Be sure not to cut too deeply, as you could damage the underlying wires. Secondly, once you've scored the jacket, use pliers or your fingers to peel it back, exposing the individual insulated wires inside. Thirdly, now you can use your chosen wire stripping tool to remove the insulation from each wire. Be sure to select the correct gauge setting on the stripper to avoid damaging the wire. Fourthly, when stripping the wires, hold the stripper at a slight angle to the wire and rotate it as you pull. This will help to ensure a clean and even strip. Fifthly, after stripping each wire, inspect it carefully for any nicks or damage. If you find any, cut off the damaged portion of the wire and re-strip it. It is important to understand the different parts of a wire stripping tool. Most wire stripping tools have several key components. Firstly, the cutting blades, which are used to score and cut the insulation. Secondly, the gauge markings, which indicate the correct wire size setting for each wire. Thirdly, the stripping holes, which are used to grip and pull off the insulation. Fourthly, the handle, which provides a comfortable grip and leverage for stripping the wires. When using a wire stripping tool, it's important to follow these safety precautions. Firstly, always wear safety glasses to protect your eyes from flying debris. Secondly, never use a wire stripping tool on a live circuit. Always disconnect the power before working on any electrical wires. Thirdly, be careful not to cut yourself with the cutting blades of the wire stripping tool. Fourthly, inspect the wire stripping tool regularly for any damage. If you find any damage, replace the tool immediately. There are some common mistakes to avoid when stripping wires. Firstly, using the wrong size stripping hole. This can damage the wire or make it difficult to remove the insulation. Secondly, stripping the wire too deeply. This can nick the wire and weaken it. Thirdly, stripping the wire too shallowly. This can leave insulation on the wire, which can interfere with the electrical connection. Fourthly, using a dull wire stripping tool. This can make it difficult to strip the wire and can also damage the wire. When working with electrical wires, it's also important to understand electrical safety. Always follow these safety precautions. Firstly, always disconnect the power before working on any electrical wires. Secondly, never work on electrical wires when you're wet or standing in water. Thirdly, use insulated tools when working with electrical wires. Fourthly, wear safety glasses to protect your eyes from flying debris. Fifthly, if you're not comfortable working with electrical wires, hire a qualified electrician. To ensure that you choose the right stripper for your needs, consider the different types available. Firstly, manual wire strippers, which require you to manually squeeze the handles to strip the wire. Secondly, automatic wire strippers, which automatically strip the wire when you insert it into the tool. Thirdly, thermal wire strippers, which use heat to melt the insulation off the wire. Also, consider the features that are important to you, such as adjustable stripping depth, built-in wire cutter, and ergonomic handle. Some advanced techniques for stripping wire exist to improve efficiency and quality. Firstly, using a wire stripper with a built-in wire cutter can save time and effort. Secondly, using a wire stripper with adjustable stripping depth can help to prevent damage to the wire. Thirdly, using a wire stripper with an ergonomic handle can reduce fatigue when stripping large quantities of wire. Fourthly, using a wire stripper with a built-in light can improve visibility in dimly lit areas. Consider also the impact of wire stripping on electrical connections. A properly stripped wire is essential for making a good electrical connection. A poorly stripped wire can result in a loose connection, which can cause electrical problems. When stripping wires, be sure to remove all of the insulation without damaging the wire. You can then use a crimping tool to crimp a connector onto the wire, or use a soldering iron to solder the wire to a terminal. The importance of proper grounding and bonding is critical for electrical safety. Grounding and bonding help to protect people from electrical shock. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker and shuts off the power. Bonding connects all of the metal parts of an electrical system together, which helps to prevent voltage differences from developing between them. When working with electrical systems, be sure to follow all grounding and bonding requirements. When troubleshooting common wiring problems, it is helpful to follow a systematic approach. Firstly, identify the problem. What is not working correctly? Secondly, gather information. What are the symptoms? When did the problem start? Thirdly, isolate the problem. Which circuit is affected? Which components are involved? Fourthly, test the components. Are the components working correctly? Fifthly, repair the problem. Replace any faulty components. Sixthly, verify the repair. Is the problem resolved? By following these steps, you can quickly and efficiently troubleshoot common wiring problems. When installing wiring in different environments, it's important to select the right type of wire for the application. For example, UF cable is designed for underground use and is resistant to moisture and corrosion. THHN wire is designed for use in dry locations and is heat resistant. NM cable is designed for use in dry locations and is not heat resistant. When selecting wire for an installation, be sure to consult the electrical code for the specific requirements. Using the right tools for electrical work is important for safety and efficiency. Some essential electrical tools include, firstly, wire strippers, which are used to remove the insulation from wires. Secondly, pliers, which are used to grip and bend wires. Thirdly, screwdrivers, which are used to tighten and loosen screws. Fourthly, voltage testers, which are used to test for the presence of voltage. Fifthly, multimeters, which are used to measure voltage, current, and resistance. Sixthly, fish tapes, which are used to pull wires through conduit. Always use the right tool for the job and follow all safety precautions. Maintaining your electrical tools helps to ensure they are in good working condition and safe to use. Firstly, clean your tools regularly. Remove any dirt, grease, or corrosion. Secondly, lubricate your tools as needed. This will help to keep them working smoothly. Thirdly, inspect your tools regularly for any damage. Replace any damaged tools immediately. Fourthly, store your tools in a safe place. This will help to prevent them from being damaged. By following these simple tips, you can keep your electrical tools in good working condition and safe to use. When working on electrical projects, it is important to follow the National Electrical Code, or NEC. The NEC is a set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC covers a wide range of topics, including firstly, wiring methods, secondly, overcurrent protection, thirdly, grounding and bonding, fourthly, equipment installation, fifthly, special occupancies. By following the NEC, you can ensure that your electrical projects are safe and compliant. When inspecting electrical work, it is important to look for any potential hazards. Some common electrical hazards include firstly, exposed wires, secondly, damaged insulation, thirdly, overloaded circuits, fourthly, improper grounding, fifthly, loose connections. If you find any electrical hazards, it is important to correct them immediately. By being vigilant and correcting electrical hazards, you can help to prevent electrical shocks and fires. Understanding basic electrical theory can help you troubleshoot and repair electrical problems. Electricity is the flow of electrons through a conductor. Voltage is the electrical potential difference between 2 points. Current is the rate of flow of electrons. Resistance is the opposition to the flow of electrons. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. By understanding these basic concepts, you can better understand how electricity works and how to troubleshoot electrical problems. When dealing with electrical emergencies, it is important to know what to do. Firstly, call 911 if there is a fire or someone is injured. Secondly, turn off the power to the affected area. Thirdly, stay away from any downed power lines. Fourthly, do not try to rescue someone who is in contact with electricity. Fifthly, wait for the emergency responders to arrive. By knowing what to do in an electrical emergency, you can help to protect yourself and others. Electrical safety in the home is important for preventing electrical shocks and fires. Some tips for electrical safety in the home include firstly, use ground fault circuit interrupters, or GFCIs, in bathrooms, kitchens, and other wet areas. Secondly, do not overload circuits. Thirdly, keep electrical cords in good condition. Fourthly, do not use extension cords as permanent wiring. Fifthly, have your electrical system inspected by a qualified electrician every few years. By following these tips, you can help to make your home safer from electrical hazards. Staying updated on electrical codes and regulations is essential for electrical contractors and electricians. The electrical codes and regulations are constantly changing, so it is important to stay up to date on the latest requirements. You can stay updated on the electrical codes and regulations by firstly, attending continuing education courses. Secondly, reading industry publications. Thirdly, joining professional organizations. Fourthly, consulting with electrical inspectors. By staying updated on the electrical codes and regulations, you can ensure that your electrical work is safe and compliant. The future of electrical technology is constantly evolving. Some of the emerging trends in electrical technology include firstly, smart grids. Secondly, renewable energy. Thirdly, electric vehicles. Fourthly, energy storage. These emerging technologies have the potential to transform the way we generate, distribute, and use electricity. As an electrical professional, it is important to stay informed about these emerging technologies. Regarding underground wiring installation, there are several methods. Firstly, direct burial, where the cable is buried directly in the ground. Secondly, conduit burial, where the cable is run through a conduit buried in the ground. Thirdly, duct bank burial, where multiple conduits are encased in concrete and buried in the ground. The choice of method depends on factors such as the type of cable, the soil conditions, and the load requirements. Proper depth and backfilling are essential for protecting the cable from damage. When dealing with electrical panels and distribution boards, safety is paramount. Always de-energize the panel before working on it if possible. Use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Inspect the panel for any signs of damage such as corrosion or loose connections. Ensure that all circuits are properly labeled and that the panel is properly grounded. Follow all applicable electrical codes and regulations. Consider surge protection devices. Surge protection devices, or SPDs, protect electrical equipment from voltage spikes caused by lightning or other events. SPD are installed at the service entrance and at branch circuits to provide comprehensive protection. There are several types of SPD available, including firstly, surge arresters, secondly, surge suppressors, thirdly, transient voltage surge suppressors, or TVSSs. Choose the appropriate type of SPD for your application.